Okay, now we're going to start our second video of definition of derivatives. This section, or this video, will cover higher derivatives and rational functions. Okay, so first we're going to review Pascal triangle, and I'm going to go up to x to the 4th degree because that's what we need for the second example. In the first example, we need x cubed. In the second example, we need x to the 4th. So remember, Pascal's triangle tells us the coefficients of a, and this time I'm not going to use a, I'm going to use x plus h to the n. And so if I have x plus h to the 0, that's 1. If I have x plus h to the first, those coefficients are 1 and 1. If I have x plus h squared, it's 1. 1 plus 1 is 2, and then 1. And that would be written as x squared plus 2xh plus h squared. If I have x plus h cubed, that's 1, 3, 3, 1. So that's x cubed plus 3x squared h plus 3xh squared plus h cubed. And then if I have x plus h to the 4th, I have 1, 4, 6, 4, 1. And that's x to the 4th plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the 4th. Okay, and we're going to use all three of those actually as we work these questions. So the first function we're going to find for definition of derivative is going to be h of t. So h prime of t, and I'm going to write this as a script h prime of t equals the limit as non-script h of t, h goes to 0, not h of t, h goes to 0, of script h of t plus h minus script h of t all over h. So that equals the limit as h goes to 0 of 2 times t plus h cubed minus 2 times t plus h squared minus 2t cubed minus 2t squared all over h. So script t prime of h equals the limit as h goes to 0 of 2, and we found this above, t cubed plus 3t squared h plus 3th squared plus h cubed minus 2 times t squared plus 2th plus h squared minus 2t cubed plus 2t squared all over h. The derivative equals the limit as h goes to 0 of 2t cubed plus 6t squared h plus 6th squared plus 2h cubed minus 2t squared plus 4th plus 2h squared minus 2t cubed minus 2t squared. Sorry, that last one should be a plus. All over h. So now I'm going to cancel. So this t should go away with that t, and this t should go away with that t. So now I'm going to factor out an h as I write the next line. So I have an h everywhere that is left. So I'm left with h over 6t squared plus 6th plus 2h squared plus 4t plus 2h all over h. So this h and the h I factored out cancel. So I'm left with the limit as h goes to 0 of 6t squared plus 6th plus 2h squared plus 4t plus 2h. Now, if I look at as h goes to 0, those three terms are going to go to 0, and I'm left with 6t squared plus 4t, and so h prime of t equals 6t squared plus 4t. All right? So now let's look at this one. So f prime of x equals the limit as h goes to 0 of minus of f of x plus h minus f of x all over h. So that equals the limit as h goes to 0 of minus x plus h to the fourth plus x plus h to the third minus x to the fourth plus x to the third all over h. So f prime of x equals the limit as h goes to 0 of minus x to the fourth plus 4x to the third h plus 6x squared h squared plus 4x h to the third plus h to the fourth plus x cubed plus 3x squared h plus 3xh squared plus h cubed plus x to the fourth minus x cubed. All of this is over h. F prime of x equals negative x to the fourth minus 4x cubed h minus 6x squared h minus 4x h cubed minus h to the fourth plus x cubed plus 3x squared h plus 3xh squared plus h cubed plus x to the fourth minus x cubed all over h. Cancel alike terms, and I forgot to write the limit. So I'm going to put a little arrow, and I'm going to write the limit as h goes to 0. Then I'm going to write f prime of x equals the limit as h goes to 0. And I'm going to pull my h out, h as minus 4x cubed minus 6, that should have a square on it, x squared h minus 4x h squared minus h cubed plus 3x plus 3xh plus h squared all over h. My h's will cancel. F prime of x equals the limit as h goes to 0 of minus 4x cubed minus 6x squared h minus 4x h squared minus h cubed plus 3x plus 3xh plus h squared. Terms will go to 0. So I'm left with f prime of x equals minus 4x cubed plus 3x. Okay? Alrighty. Now, for a rational function, what we do is we're going to do the same process, but I'm going to write my beginning definition a little differently. So I'm going to write g prime of x equals the limit as h goes to 0 of 1 over h times g of x plus h minus g of x. Now that's the same thing, right? I just wrote these as a multiplication. The reason I did it is because now when I write this here and I put it in, I get 1 over h times 1 over x plus h minus 1 over x. All right, so I'm getting a multiplication of two fractions. I'm going to find the LCD of the bracket, and so that's going to be x times x plus h. And I'm going to find the LCD within that bracket. So g prime of x equals the limit as h goes to 0 of 1 over h times, and I'm going to multiply this first bracket times x over x, and this one times x plus h over x plus h. So I'm going to do this. And that will get my LCD on each side. So I'll have x minus parentheses x plus h all over x times x plus h. Okay? So then when I simplify this, I'll have the limit as h goes to 0 of 1 over h bracket x minus h all over x times x plus h. So g prime of x equals the limit as h goes to 0 of, my x's will cancel, so I'm left with minus h over x times x plus h here, and I still have my 1 over h out here. This 1 over h will cancel here and leave a negative 1. So what I have then, scroll down just a little, is I have g prime of x equals the limit as h goes to 0 of negative 1 over x times x plus h. This h will go to 0, so what I'm left with is g prime of x equals negative 1 over x times x. So g prime of x equals negative 1 over x squared. And that's my derivative. Okay? And so now, let's look and see what happens if I have a linear function. Now you could also do this with a quadratic, but I will never give you anything more complicated than a linear function in the denominator to work on a test, because it'll get too complicated. It'll take too long to do on a test. All right? So first thing we're going to do again is write our derivative. So f prime of x equals the limit as h goes to 0 of 1 over h times f of x plus h minus f of x. And I wrote it again with it out. So this is the limit as h goes to 0 of 1 over h times 3 over 4 minus x plus h minus 3 over 4 minus x. So again, we're going to find our LCD, which is going to be 4 minus x times 4 minus x plus h. So here, in this first one, we're going to multiply by 4 minus x, and here we're going to multiply by 4 minus x plus h. Now, I'm not multiplying the denominator. I will multiply the denominator by the same thing that I'm multiplying the numerator. I'm just writing it over the top so that you understand which one we're going to do by both. All right, so f prime of x is going to be the limit as h goes to 0 of 1 over h times 3 times 4 minus x, because that's what I don't have in the denominator, minus 3 times 4 minus x plus h, all over 4 minus x times 4 minus x plus h. Now here's a little hint. Do not multiply out your denominator. There's no need to, because when you take this limit, that's going to go away and you're going to end up with the same thing in the denominator. Okay? It'll make your life easier if you do not multiply that denominator out. So that's going to be 1 over h. So that's 12 minus 3 minus 12 plus 3 plus 3x plus 3h, all over 4 minus x times 4 minus x plus h. Okay? So f prime of x equals the limit as h goes to 0 of 1 over h times, the 12's go away. This should have an x in it. The x's go away. And I'm left with 3h over 4 minus x, 4 minus x plus h. My h's are going to cancel, and that's going to leave the 3. Okay, now h is going to go to 0, so this is just going to become 4 minus x. So what I'm left with is f prime of x simply equals 3 over 4 minus x times 4 minus x, which simply equals f prime of x equals 3 over 4 minus x squared.